change of state is when matter is changed from one state, solid, liquid, gas, or plasma, to another. Sometimes it's called a phase change. The first phase change we're going to look at is melting, and that's the change of state from a solid to a liquid. The melting point is the temperature at which this happens. Different substances have different melting points. The melting point of water, if you're using the Fahrenheit temperature scale, is 32 degrees. So everything above 32 degrees will be a liquid, and everything below 32 degrees Fahrenheit will be a solid. If you're using the Celsius temperature scale, the melting point is 0. Everything above 0 will be a liquid, and everything below 0 will be a solid. The next phase change I want to talk about is freezing. Freezing is when substances change from liquids to solids, and the temperature at which that happens, which is unique for every substance, is called the freezing point. For water, it's 32 degrees Fahrenheit or 0 degrees Celsius. In other words, the freezing point of water is the same as the melting point of water. Water freezes if it's getting colder, and it melts if it's getting warmer at this temperature. Vaporization is the third phase change I want to talk about today. Vaporization is the change from a liquid to a gas, and you've seen this. You've seen it probably when you spill water on the floor. It doesn't stay there forever. The water evaporates or vaporizes. You see the word vapor in there? Vapor is another word for a gas. Evaporation is when it just happens to a puddle. You can speed it up by boiling the water, by making it extra hot. So the boiling point is the temperature at which boiling occurs, and that's unique for every substance. The boiling point of water in the Fahrenheit scale is 212 degrees Fahrenheit. The boiling point of water in the Celsius scale is 100 degrees Fahrenheit. So below 212 degrees Fahrenheit, water is a liquid, and above 212 degrees Fahrenheit, water is a gas. Sometimes we call water vapor or water steam. And the same is true for 100 degrees. Below 100 degrees, it's a liquid. Above 100 degrees Celsius, it's a gas. Condensation is the opposite. It's the change in state from a gas to a liquid. The condensation point is the temperature at which condensation occurs. You probably can guess that the condensation point of water is the same as the boiling point of water, 212 degrees Fahrenheit or 100 degrees Celsius. So if it's getting warmer, the liquid water is going to turn to gaseous water. And if it's getting colder, gaseous water is going to turn to liquid water. So just as a review, this is an image of a solid, a liquid, and a gas. It doesn't have to be water. It can be any substance. If we're following the arrows on the top in this image, you can see the solid is being melted into the liquid, which is being vaporized into the gas. That would be when you're adding energy. On the bottom arrows, it's when you're taking away energy. A gas can become a liquid, which can become a solid. So if you're adding energy to a solid, it can melt to a liquid. Keep adding energy, it can vaporize to a gas. If you have a gas and you take energy away or cool it down, you can make it condense or go through condensation. And if you cool that down, you'll make it freeze and become a solid. Now, if you're adding energy to a substance, we say that your reaction is endothermic. Processes like melting and vaporization are endothermic. They were the ones where you had to add energy to it. This graph is called a heating curve. It's what happens in a phase change when you heat something from a solid through a liquid all the way to gas. And the temperatures will change depending on what substance it is that you're heating. But in this graph, you can see that on the left-hand side at number 1, the substance is a solid. Even though we're adding energy to it, it hasn't gotten enough energy to melt. Now, when it starts melting, see how the temperature level's off at number 2? That's when the solid is changing to a liquid, and the temperature doesn't really increase, even though you're probably still adding energy. This is a phase change, so whenever there's a flat part of a graph, there's a phase change. In this case, it's going from a solid to a liquid, so it's melting. Then, once it's all been melted, you can keep adding heat, and the substance will remain a liquid. That's part 3 of this graph. It's still a liquid even though we're adding energy because we haven't reached the boiling point yet. Then at number 4, we've reached the boiling point, so we're saying that this liquid is vaporizing or turning to a gas. So that's another phase change. See how the graph is flat? That's a phase change. And then at part 5, it's a gas, which means that no matter how much energy you add, it's going to remain a gas. There's nothing else that can happen to it. These are the steps that happens when you're heating a solid as it becomes a gas. Now the opposite is an endothermic reaction, when you take heat away, when you cool something down. Exothermic reactions are things like freezing and condensation, when the substance is getting colder. This is the cooling curve. As you take away temperature, as you take away heat, the phase changes starting with gas, and as it gets colder, the gas condenses, which means turns to a liquid. And you can see that at number 2, it's kind of flattened off because it's a phase change. Part 3, how it's on a slant, that means it's remaining one state but not changing phase. In this case, it's staying a liquid at number 3. Then when it reaches number 4, the substance has gotten cold enough to freeze. So it's turning from a liquid to a solid at part 4. And then in part 5, it's a solid and it will remain a solid. That's called a cooling curve.